Let's work on converting angles that are measured in radians into angles that are measured in degrees. So remember, before we get started, the big thing that we need to know about degree measure versus radian measure is that 180 degrees is equal to pi radians. When we're working with degrees and radians, that's our most important piece of information. So we already have a fraction here that is 3 pi over 5. And the pi is our clue here. And the fact that there's not a degree symbol is our clue that this is measured in radians. So we're going to take our fraction and we're going to multiply it by another fraction. Whatever angle they have given us, that's the measure that we're going to put on the bottom of the negative of the next fraction. So since this is a angle measured in radians, we want to put pi radians on the bottom and the 180 degrees on the top. Remember, when we're converting from degrees to radians or radians to degrees, we're always going to multiply by either 180 degrees over pi or pi over 180 degrees, depending on what the situation calls for. Here, since we have pi radians on top, we're going to put pi radians on the bottom of our next fraction. This way, the two pi symbols are going to cancel and we are left with something we can just multiply. So we're going to multiply -3 times 180 on the top and 5 times 1 on the bottom and put that into our calculator. So pulling out our calculator, we're going to get, come on, a fraction which is 3 times 180 over 5, and that is 108. So this angle, 3 pi over 5, is actually -108 degrees. Let's try this again. Since this is 11 pi over 2 and there's no degree symbol, we know that this is measured in radians. So we're going to multiply by another fraction. Since this is in radians, we put the radian measure on the bottom. So we're going to put pi radians on the bottom and 180 degrees on the top. That will move us from degree radians into degrees. Now, pi over pi, those will cancel, those divide to 1. And so we are going to now multiply our fractions. So we'll do 11 times 180, multiply across the top. 2 times 1 is 2 across the bottom, and put that into our calculator. Let's use the Desmos calculator this time. So we're going to enter out of here. All right, what were we using? We're going to do, I forgot what we're using. Hold on. 11 times 180 over 2. So we'll do 11 times 180 on the top, and hitting our arrow, we'll put a 2 on the bottom, and that is 990 degrees. Notice that that is bigger than 180, and we would have gotten something similar if we had used our calculator. So 990 degrees. Now, 2. This one's a little tricky. Is it radians? Is it degrees? How do I know? There is no degree symbol, thus this must be assumed to be radians. It is possible to have radians that are just like 1, 2, 3, 4, 5. We can have any measure of radians, decimals, square roots, anything weird. It doesn't always have to have a pi in it. So how do I convert 2 radians into degrees? Well, the same way we've been doing it. We start with the fraction 2, which is 2 over 1. Since this is in radians, we put the pi radians on the bottom and our 180 degrees on the top. Since there is no pi on the top, there's nothing to cancel here, so we're just going to multiply. 2 times 180 is 360 degrees. 1 times pi is pi, and technically this is a very good answer, 360 degrees over pi. We could also put this into our calculators and figure out what this is in terms of a decimal. So 360 degrees divided by pi is 114.59 degrees. So we could also write it as a decimal worth of degrees. Either answer is correct. So let's look at this next question. The next question is, how do you know if an angle is measured in degrees or radians? How do you know? Well, if all you get is the number 60, is this 60 degrees or is this 60 radians? Since there is no little degree symbol, this is radians. Since there's no degree symbols, we know that this is 60 radians. 60 radians is actually pretty big because if we start with 60 radians over 1 and we put our pi radians in the bottom and 180 in the top, that's 60 times 180 over pi worth of radians. That's going to be a really big number. So 60 times 180 over pi, how many degrees is that? That's 3,438 degrees. So radians are actually pretty big when we think about radians.